Let's go ahead and take a look at the following. In this particular example, in 2.6, if we are given f of x is equal to 4x and g of x is equal to x over 4, then if we wanted to find f composed with g of x, which we call informally fog of x, let's remember that it's going to start with f, the first thing I see, then the circle that follows will be split open and create, if we spread the pieces apart, two parentheses, in which we're going to place what remains, which is g of x. So f composed with g of x or fog of x is f evaluated at g of x. Now, what is g of x replaceable by, which I'm going to place right here? G of x is given to be by definition x over 4. So instead of g of x in the parentheses, I'm going to put x over 4. Now, if I wish to find what is f evaluated at x over 4, what I need to do to finish this question here is to go where f is, which is right here. And right underneath where f of x is defined, I'm going to ask what is f not of x, but f of the quantity x divided by 4. So instead of x, which we see here, we're going to replace that red x by the quantity x over 4. So let's see what we get, and we can put little parentheses to welcome the change. So we'll get that f evaluated at x over 4 is 4 times, and instead of red x, I'm going to put what it stands for, which is x over 4. Now we could write this information right here, then simplify, or we could just go ahead and simplify where we are, and once we know what f evaluated at x over 4 is worth, we would go back and fill in the information at this level. So let me do all the cleanup where I am located right now. So this is 4 times x over 4, and that 4 is over 1, so those 4 cancel, and we just get x. So f evaluated at x over 4 is just x, and that's how much fog of x, what fog of x turns out to be. So f evaluated, f composed with g of x is equal to x. Now let's go ahead and find, in a similar fashion, given again f of x is 4x and g of x is x over 4, let's go ahead and find this time not f composed with g of x, but how about g composed with f of x? Let's see what we get in that situation. F compose, g composed with f of x. Let's see what that is according to our definition. First thing we say will be g. Then the little circle again splits open, becomes two parentheses, welcoming in them what we have not mentioned yet, which is f of x. So g composed with f of x is g evaluated at f of x. Let me just erase the extra things. Let's go ahead and let's continue. Okay. So let's continue here, and we'll see that we'll get that it's g evaluated at whatever f of x turns out to be. Let's remember that told us that f of x is nothing else than 4x. So instead of f of x, I'm going to put a 4x inside of those parentheses. So when we want g evaluated at f of x, we mean we want g evaluated at 4x. So what is that going to be? We need to find that out by visiting the function g over here. So we know that g of x is x over 4. So we now do want to find out what is g of not x, but in this case we want g of 4x. According to the definition, instead of the red x, I'm going to replace it by 4x. So I'll have a quotient where instead of the red x on top, I'm going to put a 4x on top, and that's divided by 4 below. So what do we do then? We need to clean that up, which is not much of a cleanup. Over here, divide by 4 and you get x. So g evaluated at 4x is going to just be x. So that's how much g composed with f of x turns out to be. So notice one thing, that in both of those problems, when we found fog of x and then we turned around and found gof of x, in both answers we got x, the same answer. And not just the same answer, it's x that we got. So we can say that f composed with g of x is equal to g composed with f of x, and both of those are worth x. So whenever that happens, that two functions, operate this way, we can say that g over here is special, and we say that g is the inverse of the function f. Now, because g is a function, and that's a key fact, then because g is a function, so g is a function, because this is the case, then we'll write g is equal to the function f, and we want the inverse of that function, so function f of which we're taking the inverse. Okay, so g is equal to the inverse of f. Let me phrase that properly. So g is the, whenever you see this little negative one here that looks like an exponent, which is not an exponent by the way, it means that we have an inverse relationship. So we say that g is the inverse over here function of f. Notice f is a function, g is a function, so g, because fog of x and gof of x are both x, then g deserves that notation, special notation that indicates that g is a function, and it is what function? It is the inverse function of our function f. Similarly, we could say that f is the inverse function of g by writing over here this notation. So f and g are inverse functions of each other. So that's a key thing. And that happens again, why? Because fog of x is equal to gof of x, and they're both equal to what? That's very important. Both equal to x. Okay. So I'll say it one last time because I didn't phrase it just right when I said it. I was writing it and I didn't say it the way I wanted. G over here is the inverse of the function f. Okay, so that's what we mean. So think about this.